And that's why I think you're all nerds. Welcome back, algebrists. And let's dig in. I have how many pieces? 2. Ronaldo, do you want to do top or bottom first? Deal. Okay, the top function is going to be green on mine. Now, I am not going to use a 3 column because it's just the function x. There's nothing to think about. So we have x, and g of x is what it spits out, or some y value. Okay, for the top function, we got 26 of y'all in here. Who wins? Top function, what is the very first x that I should plug in? Number 23, which is, I don't know. I took my list away. Who's 23? Hey, what's the first thing you want to put on for the top function?
0.
Good choice. You didn't sound super confident. You should. Always the boundary. Always. A 0. Anything else I should put next to this? Hey, it's a closed point. Now, this function's unique because it's just the identity of x. If I plug in a 0 for this x, do you agree it gives me a 0? Okay, so there's my first order pair. I need one more point here. Hook it up, number 2. On the top function, what's the another point I could use? So why? I'm going to tell you I can't use -1. Why? Yeah, give me something greater than or equal to 0. Good choice. When I plug in a 1 into x, what's it spit out? 1. Nothing crazy going on there, yeah? Is that enough? Not here. The only place that it's ever going to be not completely closed, guaranteed, is on that boundary. I think that's all I need for the top function, right? It's a straight line. Okay. However, the bottom function, what x value do you want me to pick with? Number 13? I hate the way that b looks, by the way.
0.
Good choice. How'd you come up with that?
Okay, so 0. Right there.
I'm going to fix your language because it's the
Boundary.
boundary. Okay. This one's different, though. When I do 0 for the bottom function, Hawaii, what mark do I put next to it?
Open dot,
Why?
because it's less than 0.
Okay, there's no or equal to, yeah? Cool. Open. And when I plug in a -0, what's it give me? 0? All right, let's get one more. I don't know. Any other values? What do you got? -1 will work. What's it give me?
1.
A 1. Now, this function is going to look a lot like something that we've seen before, I think. But we'll check. All right. I have all this. Are we cool to graph it? Cool. Is my graph going to be perfect? Ouch. No, I'm not going to take the time to make it perfect. It's not worth it. All right. X-axis, Y-axis. And realistically, I'm doing way more than I need. Hold on. I'm doing too much, one might say. Is that still a phrase that's floating around? Okay, fair. All right. Well, I think I can plot these points. I'll do green first. 2 points. 0, 0. Closed point right here. Obnoxiously closed. And 1, 1 right here. When I actually graph this part of my function, where should I put my pen to start? On the boundary. At the whatever x, 0, 0 in this case. You're absolutely right, Liam. So here it goes. Crazy difficult, right? Okay, let's put the other side together and see if we can't make some big connections here. The bottom function, I get the point 0, 0, and this is weird, but check it out. It's an open point, right? So here I go. What happened with that open point? Anything weird that you noticed? Yeah, so even though it's open on this side, did it still get filled in? Yeah, just by the other function. I get the point -1, 1, and I graph this. All right. I think I've seen this function before. This is the absolute value function. Like, that's it. Turns out that if we want to deal with absolute values, we can deal with it in a piecewise sense instead. It might make it easier to deal with, might make it harder, but we've been dealing with piecewise functions anytime you've ever done this without knowing it. Okay, I'm going to make one big observation right here, big takeaway. F of x equals the absolute value of x is a secret piecewise function. Like, we probably didn't notice it, and that's okay, but now we have the skills or tools to notice that indeed, it is piecewise. Okay. Last little piece. Ooh, should we graph an ugly piecewise? Okay, I'm going to let Desmos graph it, but I want you to do one last little piece for me. I want you to write as piecewise. We are not going to graph it. We are just writing the function itself. Cool. So here we go. And we're going to do one example, so I won't even bother saying A or B. For this one, I want to have y, some function, is the absolute value of 3x plus 6. Okay, couple things. First, you don't have to write it down, but I want to know from our regular absolute value function, that is the one drawn above, this has been transformed somehow. I want you to check those transformations that we saw in 1.2, either from your notes or from memory. I want you to tell me, with discussions with your neighbors, how did this move, and then we'll clean this up and make it a piecewise function together. But I want to know what transformations happened to the absolute value of x according to that. So first question is, that has been moved somehow. It's not just the absolute value of x. It's been made thinner or wider, left or right, up or down. I want you to discuss with your neighbors. How did that function? That's our first step.
If it's on the outside, we're dealing with vertical movements inside the set. 6 times 3. The slope is 3, so it's yeah. 3 is thinner, 3 is B. If it was outside of that, so that means it's a positive. It means avoid that.
5, 4, 3, 2, and 1. Okay, looking at this thing, right off the bat, is it thinner or thicker than the parent?
Thicker.
I think it's thinner. Did it move left or right? It's moved left, and I know that that feels weird. And anybody in here who was confident and said it moved 6 to the left, we actually have to make a little change. Small little change. When we looked at our transformation stuff, which you do not have to jot this down again, but you have it, I think that when we apply all the same rules, this is what an absolute value is going to look like. Those are the same rules that we saw in 1.2. Looking at this, is there any common factor inside of my absolute value that we could factor out to make this a little easier to think about? Something that goes into both of these. A 3. Everybody agree with that? So if we use that, let's just see what shakes out. A 3, and then what stayed inside the parentheses? X plus 2. Now, when we view this function this way, it's a little bit easier to see these transformations. I agree that it's a horizontal compression. It's been made thinner, but it hasn't been moved left 6. It's been moved left how many? 2. And I can see that now when I write it in this form. Okay, when we look at this, there's 2 possibilities. If whatever x value I choose makes this all positive, do I really need the absolute value symbol? So for example, and I'm just thinking in purple here, if I said the absolute value of 3, do you really need the absolute values? No, but if I said what is the absolute value of, if we do something like this, the absolute value of x equals 3, how many possibilities do we have for x? I think there were 2. One of them was x was equal to 3. What was the other one? or x is equal to negative 3, right? It just depends because both of those, the absolute value is still 3. It's how we split up an absolute value. This thing is just an uglier absolute value, right? So if we look at this, we're going to have to do some thinking, but let's start writing this as a piecewise function. F, and I'll go back to red here. I'll go to black. So from here, we have f of x equals, and there's two possibilities. If x is greater than negative 2, greater than or equal to negative 2, then everything in here is positive. I want you guys to think about that, see if you agree. If I pick x is greater than or equal to negative 2, is everything always going to be positive? You say no, give me a counterexample if not. So is that greater than negative 2 though? So it is, but if I pick a negative 1, let's just see what happens. 3 times, what's negative 1 plus 2? So do I really need these absolute value signs? I don't think so. How did I come up with that negative 2 number? King. Yeah, I just dealt with whatever was in here. I want to know when is it 0, and we got 2. Okay, if and only if x is in this value, we don't have anything to worry about. It's just this function, 3 times x plus 2. That's like I took this one. There's a plus sign here.
Why not use positive 2 for the negative 2?
For right here?
Yeah.
Because I worry about my V shape. I know that on one side, like here, it's where I have a positive slope, right? Where it spits out something positive. And I can tell right off the bat, as King highlighted, if I make this 0, because that's where my vertex will always be whenever I'm taking the absolute value of 0, what value of x made it 0? Inside all of this. If you set 3x plus 6 equal to 0. And you might not be able to do it in your head. That's okay. Help me solve this real quick. Whoa, 6, not 2. Are you sure? So we subtract 6, right? And then we get x equals, hey, look, that's that same number that we came up with. Now, we are getting a glimpse at stuff that's upcoming. Don't stress. Like, we always front load a little bit. Examples in class are always harder than, or should be harder than what you do on your homework, I think. Okay, here's my challenge for you. I'm going to give you about 90 seconds because I'm going to walk down and get some worksheets for this evening. I want you to work out the second part of this. What's the other side of it? I'll tell you, the answer is hiding in here. Everything we need has been demonstrated with that. It's a big leap for sure, but between you and your partners, I think we're going to be able to get it. I'm going to give you about 90 seconds to chat about it. Cool? Do I care if you're wrong? No. I care if you're wrong and you hide it. But I like wrong answers because it helps us learn. I like hard questions. So check it out. If this example, honestly, who thought that this was enough to help? Cool. Let's do a better one. Okay. If I want to do a little bit more complex of an example here, and again, all of this is just scratched. It's just me talking, but I want to get this to connect in our brains. In your brains? I don't know. Our collective brain, maybe. Check it out. If I wanted you to take the absolute value of something ugly, 3x plus 1. I'm not even going to worry about the bounds right now. Do you agree that there are some x's where it makes whatever's on the inside always positive for some range? If I'm taking the absolute value of a positive number, do I have to do anything? No, I'll just keep it, 3x plus 1. Everybody okay with that? The absolute value of a positive, it's already positive. Now, there's a whole other side, though, yeah? Where if I pick these x's, it spits out negative. What operation can I do that takes something negative and makes it a positive? That's not absolute value, because we're trying to split it up. Negative. Gosh, what if I just do this? This would give me the positive, where when I take the square root or the absolute value, I get the positive. This one gives me the negative, but because I'm choosing x's that make it negative, it's going to make it positive in the end. From here, all we have to worry about, and this is always going to be this easy, is 1, I'm going to put brackets around this, and I'll just put a negative right here. 3 times x plus 2. Same function, just negative. Kennedy had a great observation. She said, can I just put the negative on the 3? Yeah. Will it change anything?
Yeah.
What would it change?
The negative to 3.
So if I distributed all this, I still get negative 3x minus 6, though. Whether I put brackets around it or not is a stylistic choice. I think it's clearer with them, but you do you. What's my range, though? Like, if x is less than what?
1.
Still the same one, negative 2. Now, we have,
Why use the same one again?
because remember that we're looking at where this function changes from being positive to negative. We've already identified it. We could do the same thing. I want to know when is 3x plus 6 equal to 0. What are we going to get the second time we do it?
Negative.
Still the same number. Cool. Okay. This idea, I've never seen it presented in Algebra 2 class before, just so you guys are aware. I think it's awesome that it's in an Algebra 2 class. You guys ready to get political?
Yes.
Do you know where I stand politically?
Politics.
No. Is it any of your business?
No.
No. Do you know where I stand religiously?
No.
No. You want me to tell you?
Yeah.
Too bad. Yeah. My personal life is my personal life, my belief system. While I think it's fantastic, and I, have subscribed to my belief system for a long time, it's constantly changing. Still, like, I could be convinced to change my views with a good argument. However, lost my train of thought. There's a whole reason I was getting into this. Yeah, let's get political. Cool. Do I care about your politics?
No.
Not even a little bit. No offense. I encourage you all to be politically active, no matter who you support, what you believe in. Don't care. Your voice should be heard. Who works in here? Okay, so a lot of you guys work. I work in here too. So I'll tell you though, when I get my pay stub, somebody takes a bunch of my money. The government, man. Why? How does the government take my money? Taxes. Now, you guys all understand perfectly how federal taxes work, yeah? How do they work? 10%. No matter how much I make, they take 10%. Ooh, there's brackets.
How much you make and if you're like what? If you're like a minor or something.
So we'll pretend everybody's adults because it's going to make it easier to think about. If somebody is, and again, I don't know if this is the right way to do it. I'm not going to share my opinion on it. But should people with more money have more percentage taken out?
Yeah.
Maybe. I don't know. Like, that's not my answer. Like, some people believe firmly in a flat tax, of that 10% idea that Sebastian mentioned. Some people are very against it. If you make a lot of money, you probably don't want higher tax rate because they're going to take more money from you, right? If I make less money, is it fair that they pay less overall taxes? Maybe. Like, again, I don't know. It's not my choice. Some people say yes, some people say no. Welcome to left and right wing politics. But as we're looking at it, in the current system, we use what is known as a little extension of our piecewise, a step function. Now, I wish I'd had the IRS stuff up because I don't know the numbers off the top of my head. Do you want to use an example with taxes, or do you want to pretend like we're a business selling stuff? Okay. Yeah, so let's think about some taxes. Again, I'm just going to make a note. Non-verified numbers. Okay, this is just me making it up as an example. I don't think these are the real numbers. Cool. So, when we look at federal taxes, and we don't have state taxes here, so that's nice, but let's just think about what this kind of looks like. We have an amount of money that each person makes, and then for some amount of money, they have to pay some amount of taxes. That's how it works. So down here, we'll have money, and then percent tax. Are these numbers going to be real? No, not at all. Okay, so we'll just pick a few, and we'll put in some values. My scale is not going to be correct, just so you know. Okay, do you guys know what poverty in the poverty line is? I don't know what it's at right now, but do some families, like some people make so little money that if the government were to take more taxes, it would put them in hardship. Like maybe they couldn't buy food or power or something. Like, it happens. That group of people, typically for the U.S., it's between 0 and, I don't know the number, we're going to make one up. Let's say it's 10,000. If I don't want to write 3 zeros, what letter could I use to represent 1,000? Okay. Cool. Now, let's say the government doesn't want to just give them a free ride. And again, I don't know these values off the top of my head. What do you think is a fair tax rate for them? $0 to $10,000 annual salary. So can we just make a nice one, like say 5%? Okay, so check it out. the way that your taxes work is essentially like this, but with better, more real numbers. Between between the first $0 and up to $10,000, what tax percentage did they pay? 5%. Now, if somebody makes, let's say, 10 to 50,000, our government right now, the way it's set up, says you're going to pay a little bit more taxes. I'm going to make up a percentage. If $0 to $10,000, it's 5%. What are we charging the 10 to 50,000? 10%. Sure, and we're just making up numbers, right? Okay. They're not charged 10% until they have at least $10,000 made. So that means that, hey, once you hit this magic number, anywhere between $10,000 and what number do we say? Let's go 50. And my scale is garbage, okay? They pay 10%. So for the first 10,000 of my dollars that I make, I pay 5%. From the 10,000 to 50,000, that next $40,000, I would pay 10% in this system. And then we'll just take one more jump. Next percentage? 100 doesn't happen in this country. That's called communism. 20. Okay, and maybe the 50% or 50,000, they're going to pay 20% taxes on 50,000 to where?
100.
Sure. Now, some people make a lot more than $100,000 a year, but here's the important idea. What does a graph look like? It does look like piecewise, but alternatively it looks like steps, right? This is an example of a step function. Just so you guys can see, I did not know if you guys want to be political or not, but something very similar. If you buy a bunch of stuff, do you typically get a discount? Like if I buy one, I pay whatever rate. And if I buy 5 or more, maybe I get a discount, right? So the same sort of situation, I don't even have it open. Let me do this. We didn't do this example, but this is the one that I had made up that I thought we were going to work. I'm much more cool with taxes though. So check it out. Here's another example of a step function. If we're buying stuff, if I buy 5 of them, between 0 and 10, I'm going to pay $5. 0 to 10 items. From 10 to 20, maybe I get a discount, now it's $3 each. We would see the exact same looking graph here. Exact same. Now, the only place that these step functions get weird is that when we start thinking about domain and range. We're going to look at this example. Remember, there's a whole lot more going on, right? Back in the 1950s and 60s, the maximum tax bracket was roughly 50%, which the highest earners in the country, half of their money went to taxes. That does not happen anyway. I think I'm probably myself overall probably about 18% is what I wind up paying out of everything, but I don't make near as much money as a lot of people. Cool. All right, what's the domain of this function? Love it. Somebody can make 0, right? Now, here's the weird part. I can only see up to here. Would there be more steps over here? So how far would we go? Infinite. Now, this, whoever said 0 to 100,000, I agree with you 100% based on this, but we're assuming that, hey, there's another bracket here that keeps going and so forth and so on. Okay, here's the harder question. I want to know the range, and I want to see what you guys come up with. I'm going to give you about 30 seconds. Chat quickly with your neighbors. What's the range of this function?
We have to get taxed. So it has to be more than 0.
I don't know that you can write it where you want to. We're all there. Right, so check it out. Range is y to x. What comes first in the outline? That's how our what y values show up?
I think it'd
Do
be
you ever get 1 or 2 or 3 or 4? 5.
Oh, you can start at 0 because if you make $0, but that means you have to be the next 5, 2, and then when you get that one, then it goes to 5. We're gonna change this notation because this indicates what we're looking at. I'm gonna say
I'll show you. All right, coming back together right off the bat. I didn't see a whole lot of writing on your pages, but quick, just hands up if this is the case. On your page, you have the range starting with this. There were more than one person. Lots of people started like that. It's natural. Here's my question for you. Are there y values that we don't hit? Do I ever hit 1%? 2? 3? You say yeah. Where's my function that it touches right here? Does this ever touch it here? No. Do I ever touch at 2%? Or 3? 4? 4.5? 4.9? I don't touch it until what y value? 5. Now, in step function specifically, they have some weird ranges. This one looks like, what's that first y value we got? 5. Give me another y value that we hit. Because I can't use interval, I don't have a whole range of them. I use only 5, and then it jumps immediately to 10. I never hit 6, 7, 7.8. None of those numbers get hit. I jump to 10. Sorry, I never hit 6, 7. Nope, still didn't work. There's only one more for this function if we get rid of this part. 20. And then again, I don't know what the actual federal tax code does because we're only using this as an example. I'm just going to put, gosh, what do you call these 3 dots? Ellipses. Ellipses. It says there's more there, but I'm going to just make a note here. It's up to you if you want it. Holloway doesn't have data. And I'm going to make that caveman talk. Like, I don't know what the actual rates are. I'm guessing it does not go up to 50% anymore, but I'm not a tax lawyer either. Michael.
Can you go up to infinity for that one? Or no? Does it go up to
So you could on a lot of different step functions. This one, no, because what's the maximum percentage that they could ever take from you?
100?
Yeah, they couldn't take any more than that. So it would never go above 100. It's context specific. Now, just so that you guys have it, and I don't know if I'd call this an interesting fact, but a common step function is written as follows. It's called the floor function. The floor function, which otherwise might be called the greatest integer, is a really common, do you guys remember the symbol for integer? Somebody's looking at the front of their book. Integer is a Z like this. It's a blackboard Z. Again, I'll do it huge. I do my first one like a 7, and I just come down the other side. That's the symbol that I'd use for integers. It's not a me, it's an every mathematician thing. Okay, the greatest integer function. The way that this works, and we're going to do one of them real quick, is we get f of x, and we get to learn a new symbol. It's like a half bracket, which is weird. We're doing the floor function. So we're going to use that symbol, and we'll just do an x here, and we'll do this symbol. Notice it's like the bracket without the top part, yeah? Okay, this one's the floor function, and we'll see how this works. Just purely out of seeing if we can come up with, like, deduction, what do you think this function would be called if we did this? The ceiling. This would be the ceiling function. Absolutely. Okay, so let's look at this. We're going to pick the first integer, how this really works. First integer less than or equal to x. That's all that this tells us. If we were doing the ceiling, it'd be the first integer greater than or equal to. Seabass.
Is it the floor sign?
This is the floor symbol. Yep, right here.
The L?
That little bracket without the top. Yep, that's our floor symbol. So, I'm going to use a number line when we graph this. I don't want you to. Okay, so let's get some values. And we're going to make a few points, and you're going to help me build this table real quick. And then we'll have like 8-ish minutes to start working on the homework. Cool. Give me your next value. Don't care what it is. 1. What is the greatest integer less than or equal to 1? So 1 is an integer. Should we review real quick what the integers are? I'm going to count like very few of them. -3, -2, -1, 0, 1, 2, 3, 4. Those are the integers. Okay. It's not all reals because no decimals are allowed. It's only the whole numbers, positive or negative, including 0. So if we think about a number line, and again, you should not draw this, but I want you to think about this as we do it. Okay. Bless you. Is 1 an integer? So what's the first integer less than or equal to 1? 1. Deal. I need another value. I'm going to pick another one. Between 1 and 2.
1.2.
So we got 1. 1.2. Is 1.2 an integer?
Yes, no.
So check it out. I have 1 and 2 right here. If I try to put 1.2, it's not an integer. And it's actually about here. The first integer less than or equal to that, though. If I start working left, what's the first integer that I hit?
-1.
It's still 1, isn't it? If I pick 1.2, which is like right here, that's not an integer. I work backward until I get to 1, and it's right here. What if I pick, like, I don't know, 1.9? Is that an integer? So if I went to 1.9, it's not an integer. I go to the left until I hit an integer. What's the first integer I hit? 1. When's it going to change? Right at 2. The second I get to 2, what is it? 2. What about 2.314? 2. And it will stay at 2 until I get to where? 3. Do I have to keep making my table? Because check out what happens. We can graph all of this really quickly, really easily, just if we can see the pattern. So here we go. I'll take a little bit of time. I'm only going to do a few of these steps because there would be infinitely many normally. X and Y. And here we go. I didn't pick 0, but what's the, Chetty, I haven't called on you. What's the first integer less than or equal to 0? 0. So check it out. I get the point 0, 0. Now it would stay at 0 at 0.5, at 0.6, 7, 8, 9, until we get to what number? 1. So I'm going to put a 1 on my scale just so I can see it. And a 2. And we might as well do a -1 and -2 while we're at it. And a 1 and a 2. Sorry, 1 and a -1. So check it out. Let's see if we do indeed build steps. I'm going to be at 0 until, gosh, you know, I just have a attention span of a goldfish. I was at 0 until when? Until 1. Now, all of a sudden, magically, it seems, I'm going to make this bold just so I can see it. Once I get to 1, my function jumps up. The second I got to 1, my step moved to where? 1. And it stays at 1 until I get to where? 2. Do you think you can see the pattern showing up without me doing all the table? Where's my next step? So at 2, I step up, and it's all the way up here now, right? And it goes this far. And again, I don't have my scale. Could I just keep this going forever? Yeah. Would it go the other direction too? Like, it gets weirder and that number line gets more and more important, but I think I can see my steps at -1, at -2, all of these. Okay, last little piece. Step functions. Here it is. They follow all the exact same rules that our transformations did. I'm not going to make you do it, but we're going to talk about it. This is just to talk about. What if I did this? How has this changed? Right 1, up 1, and that 2 was a horizontal stretch. Gosh, what does it look like if you, or sorry, vertical stretch. What does a vertical stretch look like here? It doesn't really make sense to say thinner or wider, although you want to. My steps, if I look at a thinner function, would my steps just be smaller? Like, that looks thinner to me. It looks weird, but that's a thinner in this context. Okay, for these, just want to talk about those transforms and see, look, they still apply. What's the last question I'm going to ask you about this graph? Hey, tell me the domain and the range of this function. I'm going to do the domain for you. It's all real numbers. I want the range.
0, 1, 2, dot, 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 dot. 0, 1, 2, 3, okay, just because she didn't go 1, 2, 3, 4.
All right, so check it out. We could start and never end. Do I hit 0?
Yeah.
It's right here. Do I hit 0.5?
Yeah, no.
Do I?
No.
No. So 0, 1, 2, 3, negative 1, negative 2, negative 3, negative 4. Gosh, if only there was a concise way to write all that down.
Yeah, I know.
It's the integers. It's just the integers. It's not the whole numbers or it's not the real numbers. No decimals. The greatest integer function, its range is simply the integers. We will only hit the numbers 1, 2, and I'm not going to do this whole list. But if you'd rather write the integers this way and just never want to learn that shorthand, I'll let it slide for now. On my graph, I have negative 2, negative 1, 0, 1, 2, 3, and how high up does it keep going? So you could spend forever writing this list, or you could just write the z that says, hey, all these numbers. Cool. Piecewise functions. Less scary than they were before, or just as scary now? Okay, well, we won't really know until you get some practice, yeah? Let's get some practice. I'm hopeful that this will be the last worksheet that I have to give you. I'm not a big worksheet guy, except you guys don't have equal access to the textbooks, which I'm sorry, it's still blocked. But cool.